Okay, so this is 2.4, number 23. We're supposed to find a non-zero matrix A for which A squared is 0. Some of y'all noticed that this would be a really very much easier question, right? If the non-zero part of that weren't in there, right? So obviously the zero matrix squared is the zero matrix. Okay, cool. Good thing to notice. Anybody come up with an example?
Yeah, I got -1, 1, -1, 1.
-1, 1, -1, 1. Cool. So you guys believe that this gives you the zero matrix if you square it? Yes? Pick up, drop out? Yeah, really this is that the columns are perpendicular to the rows, right? Cool. Any matrix where the columns were perpendicular to the rows would work. Did anybody come up with a different one? What do you got, Leah?
I got 0, 1, 0, 0.
Ah, that's the correct one. So I was talking earlier about the distinction between right and correct, and I just want to get it on the video. So this one is right. This one is correct. I'm going to use that distinction here for, there are lots of right answers to some of these. There is one answer that's written in the base code of the universe for this. That's this one. So, why? Like, what is the geometry that would cause you to come up with this? What does this matrix do geometrically?
It outputs the x component of something, or y.
Okay. So, this is important enough that I'm going to actually multiply this by a vector xy. So if I take this Leo's matrix and multiply it by the vector xy, I get a vector which has only an only a non-zero x component, right? And the non-zero x component is y. If I do this twice, it kind of gets fed off the top, right? You guys see what I mean talking about feeding? I'm talking about this vector here being like fed into oblivion, right? I'm thinking about it like a tape on a Turing machine. So I'm scooting it up a spot. This one drops off and I'll fill the place that it, or the number that comes in with 0. Okay, see that? Okay. So the question is, does that give you geometric intuition for why you can come up with a matrix with a squared not 0 where a cubed is?
Yes.
Okay. How do I want it to act?
Well, the way that I had mine act is I essentially made it take a z component, put it in the y position, and then an x component, put it in the z position, and then it just zeroes out the x position.
Okay. Let's see, so it feels like that one did a little bit of switch swapping around. You guys with me on that? I think I believe that certainly if you square that matrix, right? So what's your actual matrix for this?
0, 0, 0, 0, 0, 1, 1, 0, 0.
Okay. Cool. Yeah, I think I believe that if you cube that, you'd get 0. Did anybody come up with the correct answer? Not to drag. This is it's very nice. It really is. Did you come up with the correct one?
I mean, I gave it with an alternative. I think it would have arrived at, but
Okay.
I don't think it's the correct answer.
So I think that I remember yours, Alex. I think yours was
0, 1, 0, 0, 0, 0, 1, 0,
So that one puts y in the x position and x in the z position. That one also feels like it's mixing things up just a little bit. What if I thought about that same feed technique? Like these are both right. Down with that.
Would the correct one just push y and z up and then kick out x?
Yeah, so I'm gonna just take this tape, right? And I'm gonna scoot it all up a position. I'm gonna forget the x. I'm gonna put a y and a z here, and a 0 at the bottom. And then the squaring of this matrix, right? So if I do a squared, it's easy to calculate what that's going to give me, right? So if I do a squared to x, y, z, I'm going to get z 0, 0, because I pushed y off the top of the tape. You guys with me on that?
Would the matrix be 0, 1, 0, 0, 0, 1, 0, 0? Wait, do you
Sorry, give me that again, slower.
0, 0, 1, 0.
Yep.
0, 0, 1.
Yep.
0, 0, 0.
Yep. Absolutely. Perfect. And you guys see how that's really close to these? They're just all a kind of a permutation off from one another. Very cool. Ian was on that?
Not really. That's what I was talking about. Oh, is this recording? I'll
Yeah.
stop talking.
Come on, dude.
Remember when I was like talking about worlds and talking about permutations a little bit, and then I went off. In my head, if you were like in there, it would have made sense.
Okay.
But
Cool.
that's kind of what I was trying to.
Yeah, so you can think of these, they're not quite projection matrices, right? You guys see that? They're a little bit different. They're like a rotate by 90 degrees and then project.
So like compression, I guess.
Yeah, compression matrices are kind of a perfectly reasonable way to think about this. So I said earlier that projection matrices are kind of my cartoon for a matrix that's singular. These are singular matrices that aren't projections, right? So it's only that I'm using projection matrix as a cartoon, not that it's actually associated with singular matrices. Does that make sense? You guys all see that these matrices are singular, right? How do I know for a fact that these are not invertible? Yeah, there's a row of zeros, so it's pretty obvious that the rows are what? Good. The rows are obviously linearly dependent because there's a row of zeros. Check. Done. Easy. These are not invertible. Another way you can see they're not invertible is like, dude, if you do this a couple of times, you get to the zero matrix. You ain't getting back from that. You guys see that? Like, if I apply the inverse matrix, I should get back. So if I'm thinking like, okay, maybe I had this case where I had like, let me just suppose I had a squared was the 2 by 2 zero matrix, and also it was invertible, right? If that was the case, then if I took a and a, that's a squared, right? But if I multiplied that by a inverse and a inverse, I should get to the identity matrix, right? These two would group together, be the identity matrix. Those two would group together and be the identity matrix. So I'd be saying, okay, so on the one hand, that's the identity matrix. But on the other hand, that's the 2 by 2 zero matrix times some garbage, right? And that's gonna be the 2 by 2 zero matrix. So I'd be saying the zero matrix is the identity matrix. That would be a problem.
That's
You guys with me on that? Okay, cool.